Welcome back, Math 30-2, to your third lesson on permutations and combinations. In this lesson here, we're going to look at permutations and how permutations work when we have restrictions in the problems. I'll show you what I mean here eventually, okay? So let's take a look at here. We have how many ways can all the letters of the word oranges be arranged if there are no further restrictions? Okay, so there are no restrictions. It wants us to use I, fundamental counting principle, which is, well, how many letters are there? 1, 2, 3, 4, 5, 6, 7. So, which is 1, 2, 3, 4, 5, 6, 7. 7, 6, 5, 4, 3, 2, 1. And that's it. Okay? And we multiply all those together, which is going to give me 5, 0, 4, 0. Okay? Remember that from last lesson. Now the next one, let's look at number 2. Is easier. We could just say 7 factorial, and that's going to give me 5, 0, 4, 0 as well. Okay? So those are the two ways of doing it. Now B says the first letter must be an N. So the first letter must be an N. 1, 2, 3, 4, 5, 6, 7. So if the first letter is an N, we only have one option for that. Now the N's used. So what do we have left? 6, 5, 4, 3, 2, 1 to choose from. So I multiply that together, that's going to be 720. Or in other words, we could say this is the same as 6 factorial. These all have multiplication signs in between. 6 factorial, which is equal to 720. Okay? So there's one type of restriction, is for starting with something. Now, here we go. Let's take a look at the next one. It says, 3 girls and 4 boys are to be arranged in a row for photograph. Now, we want to know how many ways can this be done if there are no restrictions as to where each person stands. So the girls probably don't look the same. They're not identical. They're different people. Same with the boys. So altogether, we have 7 factorial because there's 7. There's 3 boys and 4 girls, or 3 girls and 4 boys. So that's a total of 7 children. So it's 7 factorial combinations we can have. Okay. Now the photographer decides that he could take a better photograph if no 2 people of the same gender are together. So you can't have 2 boys together or 2 girls together. So let's try and show the arrangements below. This one here, we would have to probably start with the boy because there's 4 boys. So we have boy, girl, boy, girl, boy, girl. We have to go that way. And then boy again. If I started with a girl, then it'd be boy, girl, boy, girl. If we done our girls, it would have to be boy, boy. So we can't start with a girl, we have to start with a boy. Now if I look at this, determine the total number of arrangements. Well, if I look at this here, there's 4 boys, 3 girls. 3 boys, 4, or 2 girls now. This one's already being used. 2 girls, 2, and then we have 1, 1. Okay? So, altogether, this is 4, 3, 2, 1. That's 4 factorial multiplied by 3, 2, 1. 3 factorial. That's 4, 3, 2, 1. That's the boys. So boys factorial multiplied by girls factorial. And that's an easier way of doing it. And that's using our permutations and combinations and factorials. Or I can punch all that into my calculator. So those are the 2 ways of doing it. So this is going to be, let's plug that in, 4 factorial multiplied by 3 factorial. So let's try that out. 4, and we go math, and factorial, and we want to multiply that by 3. Math, and we get factorial. Enter. That gives me 144. Okay? Which is the same as 4 factorial is 24, 3 factorial is 6. Okay? Now, next one says, 6 actors and 8 actresses are available for a play, with 4 male roles and 3 female roles. How many different casts are possible? So we have 6 actors and 8 actresses. Okay, so 4 male roles. So out of the 6 actors, we want to pick 4. And out of the, every time we say and, we're going to multiply. Out of the 8 actresses, we are going to pick 3. So we put that into our calculator. So I have 8, and I go math, where's math, go over, pick 4. I'm going to put it in brackets. And we're going to multiply that by, we want, oops, 8, pick 3, sorry, there's 3 females, and 6, and we're going to go over to math, and we're going to pick 4. Enter. I put that in, I always make sure I have my brackets. I get 120,960. So there is a total of 120,960 different combinations of the rolls. Okay? Because if we say rolls, it doesn't matter if Jimmy's playing, if it's like Hammett, Jimmy's playing Hammett or whatever, different characters are different roles. Okay? It matters which role. So let's take a look at question number 4. Okay, let's look at question 4 here. Andrew is asked to determine the number of arrangements of the letters for the word brains, okay, in which the vowels must be together. Now, he came up with this reasoning below. He says, since the vowels must be kept together, he will keep A and I as one element AI, okay? This means that I now have 5 elements instead of 6 to arrange, because there's 1, 2, 3, 4, 5, 6. But if he keeps these together, there's really only 5 elements, which are AI, B, R, N, and S. Must be arranged in 5 factorial ways. Okay, so his answer is 120. So now it says, is Andrew correct saying that AI should be combined together as one element? Well, yes, he is correct. Okay, for that one, he is correct. A and I must be together. Now, Andrew's final answer is not correct, though. Explain why, or what is missing from his reasoning. Well, AI must be together, but we could also, AI could also, if the vowels must be together, AI, we can also have I, A. So, he only has half the answer. Now, if we look at this, there's 2 arrangements. Since there's 2 letters, those 2 could be arranged in any way. So it's 2 factorial for the way these 2 could be arranged. If you had 3 vowels that must be together, it would be 3 factorial, and then multiplied by 5 factorial, because then it's part of these are the kept together. Okay, and this is the new total. Okay, because the 1 digit now has a value of 2 instead of having a value of 1, because it could be AI or IA. So if we multiply these together, we're going to get twice of what he has, which is 240. Okay, so there are 240 different ways. Or in other words to say is 2 multiplied by 5 factorial. Okay, so find the number of permutations of the letters kitchen if the K and C and N must be together. In the order, though, K, C, N. So looking at those, it must be in that order. Now, if they must be in that order, this is the only combination. So there's only one for that one. Okay? It's just like this. I can't go C, K, N, so there's only one way of putting these together. But there were at first 1, 2, 3, 4, 5, 6, 7 different letters. So now, if we have these 3 together, this is all one letter. We have 1, 2, 3, 4, 5 different letters. So now that's multiplied by 5 factorial. Okay? And if I do that, I'm going to end up getting 120. Okay? Now, let's take a look at the next one. The letters K, C, and N must be together, but not necessarily in that order. So K, C, and N could be arranged any way possible. So that's like 3, 2, and 1. Just for that one term, or that one digit, we have 3 factorial permutations for 1 digit. Okay? Then, now, because these all count as 1 digit, we have a total of 5 other digits. which gives me, we have 120 multiplied by 6, which is 720. Okay? Or we could plug that into our calculator. Last question, number 6. It says, we have Frank, George, Hannah, Iris, Jacob, and Kim have playoff tickets to a hockey game in adjacent seats A3 to A8. So they're all next to each other. All 5 of them. 1, 2, 3, 4. Oh, all 4 of them. Oh, 1, 2, 3, 4, 5, 6. All 6 of them, okay? How many different ways could they sit together in seats A3 to A8? Well, that's 6 factorial. So different people. Order could change. Now it says George and Hannah are dating. How many different arrangements would they be if they must sit together? So now George and Hannah must sit together. So these two are now 1. But it could be Hannah and George or George and Hannah. So that's 2 factorial. But they count to represent their digits, you might say. Now all the others, we have 1, 2, 3, 4. Oh, 1, 2, 3, 4 others. I'm including them as 5. Multiplied by 5 factorial. So that's going to end up giving us 240 different ways. Okay? Kind of like what we did up here. Now the next one says, just before the game, George and Hannah have a disagreement and decide not to sit together. How many different arrangements would they be sitting together? Okay? So now we have to look at how many different arrangements would they be sitting together. This is 240. Now, this tells us, oops, this isn't 240, this is 6 factorial 720. We did that a bit earlier. It's kind of similar to that because that's like 6 and then 5 factorial, 720. So these are all the amount of arrangements where they could be sitting together. These are all the possible arrangements. So I'm going to have to go 720 minus 240, which is going to end up giving me a total of 480 arrangements. So I did all the ones of them of possible sitting situations, subtract all the ones of them sitting together. Okay? So I just did answer A, subtract B to get my answer of combinations or permutations. So that, or sorry, I should say my answers of permutations. Combinations are a bit different. So that's the different amount of orders they could have. So that's everything. Hopefully you understood this. As I see you tomorrow, we work on this together.